I'm pleased to have an opportunity to tell you about some important new research related to the circular economy. So, earlier in the conference, you heard Yanis Potocnik make some brief mention of the study shown on this slide. I'm now going to give you a more detailed introduction. So why present this research at a conference on the circular economy? Because this research examines, in a very careful and systematic way, the potential contribution of material efficiency to the reduction of greenhouse gas emissions. The study focused on homes and cars, primarily in developed countries, for reasons that I will explain in a minute. The study had two parts: quantitative modeling of the contribution of material efficiency to greenhouse gas emissions reduction, and a review of related policies. I was the lead author on the policy review. I'll start with a quick introduction to the International Resource Panel, called the IRP, which conducted this study, and then I'll provide an overly quick summary of the results of the quantitative analysis done by my colleagues in the modeling team. Then I'll turn to some highlights of the findings about material efficiency. All right. So the IRP is an international group of scientists working under the auspices of the United Nations on research issues. A simple way to think about the IRP is to resources what the Intergovernmental Panel on Climate Change is to carbon and climate change. Since its inception, the IRP has published 32 assessments covering diverse topics such as metals, land use, forests, cities, decoupling, resource efficiency, renewable energy, and more. Back in 2017, the IRP published a report commissioned by the Group of 7 countries entitled Resource Efficiency, Potential and Economic Implications. The Group of 7 countries include the US, Canada, the UK, France, Italy, Germany, Japan, and the EU. That report provided evidence that increased resource efficiency is not only practically attainable, but also contributes to economic growth, job creation, and climate change strategies. As a follow-up to this work, the G7 asked the IRP to estimate greenhouse gas mitigation potential of resource efficiency related strategies. The response to that request is this resource efficiency and climate change report. Okay, let's turn to the quantitative analysis. The rationale for this analysis is the overlooked yet important role of materials in greenhouse gas emissions. Materials have become more important as a share of global emissions, growing to over 11 gigatons and nearly a quarter of global emissions in 2015. The largest emissions are from the production of iron and steel and other metal, cement, and construction materials. Both steel and cement production have process-related emissions that are hard to abate. Until technology becomes commercialized to lower process emissions, reducing the demand for emissions-intensive materials is the primary way to reduce emissions from the production of materials. Let me put this another way. Efforts to address global climate change have traditionally focused on improving energy efficiency and accelerating the transition to renewables. While this is key, we need to pay greater attention to material efficiency, as without it, it'll be nearly impossible and substantially more expensive to keep global warming below the 1.5 degree centigrade target in the Paris Accords. This study examines how much material efficiency can reduce greenhouse gas emissions in addition to improvements in energy efficiency and a shift to renewables. So how can material efficiency reduce greenhouse gas emissions? There are strategies that address different stages of the life cycle of products. The strategies are intended to reduce, again, the need for the production of materials. So if you look at these circles on the diagram, some of them will be very familiar. In the lower left, there's improved recycling, there's the recovery and reuse of components, and then product life extension, making products last longer. In the upper left, using less material by design, what many of us call lightweighting, or material substitution, that is, for example, using wood in place of steel or cement. Fabrication yield improvements refers to strategies to use all the material inputs in the product, not generating scrap. And the most important, it turns out, is more intensive use. And with that, so using a product more intensively includes various ways of sharing existing products and thereby requiring fewer products to provide the same service. So with this focus, the IRP report looks at important material intense sectors. Most materials are used in construction and manufacturing, and within these sectors, private vehicles and residential housing are particularly important because they use large amounts of materials, they provide essential services to society, they create high economic value, and they show significant potential for system-wide efficiency increases. Looking at residential buildings, homes in the G7 countries, we can see that in 2016, construction materials, that's the part shown in orange on these bars, contributed about 20% of the building-related emissions. Assuming a shift toward cleaner energy sources and increased energy efficiency, separate from the efforts toward material efficiency, we expect a substantial decline in emissions by 2050. That's the second bar. Implementing the 7 material efficiency strategies on top of this, emissions can be reduced by another 35%. Greenhouse gas emissions related to the material cycle of buildings would go close to zero. Emissions from energy use would decline because of the reduced area that requires heating and cooling. As the last slide shows, the report looked at a comparison of annual emissions scenarios in the year 2050. The study also checks what the implications are for the cumulative emissions from today up through 2060. The reduction from, G7 homes are about 20% through material efficiency strategies. This, of course, depends on how fast we start implementing them. We can also see that more intensive use of homes, fewer square meters per person, the purple segment in this chart, would save by far the most emissions. Better utilization of space means less need for new building, plus freed materials that could be reused for other purposes if recycling capabilities are in place. Leaner design has less impact, interestingly, in the G7 countries because new building need is low. It would have more impact in growing countries like India. All right, let's switch to cars. Looking at the whole fleet of cars in the G7, given the long driving distance in the G7 today, most emissions are related to fuel supply and tailpipe emissions. That's why the blue bar is so big. For 2050, the modeling assumes, separate from the material efficiency efforts, a significant share of electric vehicles and a substantial reduction in the carbon intensity of electric power. This means this results in substantial reductions of greenhouse gas emissions. When you add material efficiency on top of this, you can get a further reduction of 40%. Okay, so let's look at the strategies for cars. It's clear that ride sharing or carpooling would have massive benefits. Note, this is not Uber and Lyft. That's a different strategy. This is sharing of cars or having more people in the same car. Using cars from shared fleets for individual rides would also be beneficial, and so would using, on average, smaller, more need-appropriate vehicle sizes. All right, let me sum up. Overall, in this model, all strategies in both sectors would reduce G7 emissions by 20 gigatons. That's, again, about 20%. In India and China, this would be about 36 gigatons, or about 25%. Given that the entire carbon budget for G7 countries up through 2060 is only 50 gigatons, these reductions are important, though it's important to understand that they're not enough. To keep temperature increases to 1.5 degrees, all material efficiency strategies need to be implemented as fast and as extensively as possible, and they need to be combined with other ambitious measures such as deep energy retrofits of buildings, a greater shift to public transport, fast introduction of electric electric vehicles and clean energy, and innovation in low carbon materials production. All right, so given that background about what the quantitative analysis revealed, let's look at policies. When we started this research, our focus was on policy evaluation. We wanted to know what existing research could tell us about how effective material efficiency policy has been in reducing greenhouse gas emissions. As you'll hear, we were disappointed to find very little policy evaluation. So the research evolved to focus more on documenting and describing policies. By the way, RECC is just the abbreviation for the name of this study. So what you see here is a representation of all the different parts of the economy where policies could be related to material efficiency. We've got the homes and cars in the center, and then the representation of the product life cycle. So policies could address the various stages in the life cycle, and the 7 material efficiency strategies. That's a lot of different places in the economy. There are also policies that cut across the life cycle and sectors of the economy. What we found was that while there were studies of the greenhouse gas emission impacts of some strategies, there were very few studies that encompassed together policy, strategies, and outcomes in terms of both material use and greenhouse gas emissions. So let me emphasize this. If you look at the bottom of the slide here and you see the arrows, in order to understand whether a policy, a material efficiency policy actually gets us to a reduction in emissions, you have to start by looking at the policy and asking, does it in fact lead to the adoption of material efficiency strategies? And then do those strategies actually produce desired results? Presumably fewer tons of material used. And finally, does that reduction in material use actually lead to greenhouse gas impacts? That's a lot to figure out. Overall, we found a lack of what's called ex post policy evaluation. That is, after the policy has been in operation, and that ex post policy evaluation is the evaluation that happens after the policy has been in place. And there's also a disproportionate focus on end of life and landfill diversion rather than other aspects of material efficiency. All right, let's talk about some specific examples. Because of the limits of time, I'll just talk about homes and won't be able to talk about cars. So, material efficiency policies for residential buildings. It turns out that design is crucial, both crucial and cross-cutting for material efficiency. It influences multiple strategies for material choice, construction technology, building use, and end-of-life management. However, design is typically not subject to regulation, but when building standards become building codes and are adopted by governments, they become de facto policy. We found that of the standards and codes that are related to the environment, almost all focus on energy. So, looking more closely at standards and codes, we found both good news and bad news. I'll highlight just some of these findings. So on the good news side, the CARB, the California Air Resources Board, found that LEED, that's a building certification system, was associated with substantial reduction in greenhouse gases. And there's a new development in the world of building codes. The International Green Building Code has been developed, which has standards for many things, including some that are related to material efficiency. And it's been widely endorsed by professional associations and other institutions. And according to the International Energy Agency, a lot of countries have building energy codes in place. And let me now turn to some of the more disheartening news. We did not find any examples of for codes that addressed material efficiency specifically. And this wonderful new green building code is actually being fought by the housing industry, at least in the US. Standards can actually work both ways. In the case of concrete, there are standards that mandate at least a minimum level of cement, making it hard to engage in a less material by design strategy. And quite important, the International Energy Agency found that voluntary standards are not effective, only mandatory standards. And also the progress in the adoption of environmentally related building codes, energy codes for the most part, is not keeping up with the increase in floor space, that is, in growth in buildings. Let me focus even narrower here. One of the well-known building certification systems that evaluates and rewards with, in a sense, a badge for buildings that meet certain environmental criteria is called LEED. And we discovered that in the US, local and state governments were taking parts of LEED and putting them into their policies. The good news is that the adoption, as you can see from this graph, has been substantial. And this eases policy development for these subnational governments. They don't have to create the codes all by themselves. But it is complicated because how much the use of standards like certification systems like LEED gets to material efficiency depends very much on the specific way that the point systems are set up. So another part of material efficiency for buildings, this relates to actual construction. And thus using less material by design or reducing the generation of waste on construction sites. This can be facilitated by the use of building information modeling and by prefabrication and modular construction. BIM, as it's called, is modeling a building project in a three-dimensional software environment through collaboration with architects, engineers, and contractors. Prefabrication is the production of building components offsite in a factory environment and their assembly at the building site. So both of these reduce material use and design, fabrication yield improvement, that is less scrap, more use of the actual material inputs, and the facilitation of deconstruction, that is taking apart a building at the end of life so that the components and materials can be reused. Interestingly, the use of these technologies is one of the places where there are overt policy mandates. In the UK, Denmark, and the state of Wisconsin in the US, there are mandates for the use of BIM or prefabrication in public buildings. Singapore is especially advanced in policy mandating prefabrication, in that case as a way to address labor shortages. There are some studies of the environmental impacts of BIM and prefabrication, but no significant policy evaluations were found. Okay, we're switching now and looking at taking a more detailed look at the material efficiency strategy of increased intensity of use in homes. So again, increased intensity of use in homes translates into less space per person, and strategies commonly discussed include shared and multi-purpose space or smaller dwellings tailored to need. Now, shared space has been around for a long time. Think of roommates sharing flats or apartments, buildings with shared common areas, gyms, laundries, lobby gardens, and the like. There are newer versions of sharing that focus on shared kitchens and other designated communal spaces. There's also the emergence of digital peer-to-peer lodging. In simple terms, Airbnb and similar endeavors. And that is an attempt to make use of idle assets, underused space. However, I'm not going to go into the Airbnb phenomenon because it actually doesn't relate to housing, since it mixes residential use with tourism. And there's a lot of uncertainty in terms of the trade-offs in terms of rebound effects. Another idea that's been around for a while, and given the global pandemic, has become particularly timely is telework or telecommuting. I'm sure we'll have more insight into the impacts when researchers finish crunching numbers on the worldwide natural experiment of telework that we've all been taking part in over the past year or so. So, policies. Generally speaking, we can say this whole topic and the whole topic of policies around more intensive use of homes and their impacts is vastly understudied. Another way to approach more intensive use is to reduce the size of household dwellings. So, however, it probably won't surprise you that we didn't find policies that seek to reduce space per person in order to reduce material production and consumption. In fact, some countries have policies that seek to set a minimum space per person in order to reduce crowding. In addition, reducing house sizes will face barriers. Zoning is an impediment, famously in the United States. The way that homes and assets are taxed often runs counter to tailoring the housing size to household needs. That is, there are incentives not, for example, to downsize. And for many households in many countries, homes are actually an investment and a form of financial security. All of these can be impediments to lowering the size of homes. So actually, let me go back a step here and say that these provide incentives to stay in the same home, and what this prevents what you might call right sizing, that is, moving to smaller homes when, for example, children are grown, on the other hand, to larger homes when families grow. Policies that remove those barriers for those seeking to downsize as a result of a transition in life stages, for example, children leaving home, divorce, or death of a partner, are perhaps less politically challenging and offer an opportunity. Let me sum up on material efficiency strategies. The modeling, the quantitative analysis suggests that by far increasing the use intensity has the highest payoff. But there are very few policies aimed at enhancing material intensity in order to improve material efficiency. Use intensity. Policies can also be barriers as well as facilitators. And finally, we actually don't know a whole lot about the impacts of the policies. All right, another switch here. We're going to talk just briefly about cross-cutting policies. There are a whole variety of policies that cut across economic sectors and life cycle stages. These are addressed in the report. Given the time constraints, I'll mention just one: green public procurement. So it's well known that governments often use their purchasing power to advance various goals, including environmental purposes. It's much less common for GPP, as it's called, to be used specifically to advance material efficiency. The rationale for green public procurement is clear, but its outcomes, its results are less clear. Most OECD countries, however, do have GPP in place. One of the key questions in this case is, can we actually draw conclusions from government purchasing programs to changes in the net reduction, that is, changes in the emissions of greenhouse gases? This means that life cycle measurements are needed. Let me give you one example of an actual life cycle based policy. In the Netherlands, there is a life cycle policy for the procurement of infrastructure. And part of that uses a software called DuboCalc. It's life cycle based software that quantifies a wide range of environmental impacts of construction materials. And based on the materials used, DuboCalc calculates what they call an environmental cost indicator, a single value for all the environmental effects based on the cost of preventing emissions. That value is used as part of the tendering procedure in procurement. And so what happens is that the cost of the bid is evaluated as a sum of the conventional costs and this environmental cost indicator. So let me wrap up here and talk about the key findings. So in many cases, policies simply don't exist for material efficiency strategies that focus on the upstream part of the product life cycle. And that's because the strategies that occur upstream are often not recognized as addressing material efficiency. And we found that there was, as I said at the beginning of this talk, a disproportionate focus on end of life, recycling, and related things, rather than on the impacts of end of life choices like greenhouse gas emissions. There's a real need for sophisticated policy evaluation, especially after policies have been in place and operating. And finally, life cycle framing and evaluation is really needed. So thank you very much. I'm pleased to have this opportunity to talk to you today.